Good morning. In this video, we are going to talk about proposition 14 from book 1. So this proposition tells us that given a straight line and a point on it, and two straight lines across this point and lies on different sides of this given straight line, and the adjacent angles, the summation of two adjacent angles are two right angles, then these two straight lines are in the same straight line. Okay, it's probably a little bit complex, but let's see this example. Let's say AB is a straight line and P is a point on it, and PC and PB are two straight lines through this point and lies in the different sides of AB. Okay, this side, they are in different sides, and the adjacent angles in these and these, the summation of them are two right angles. Okay, and the proposition states that CP and DP are, these two straight lines are in exactly the same straight line, which means points CPD are in the same straight line. Okay, so let's give it a proof. We are going to use the proof or contradiction again. If you can't remember the method, just recall proposition 6 and 7 from book 1, where we have used this method. So the first step is to make a hypothesis. This proposition says that these two lines, straight lines, are in the same. So we just suppose CP and DP are not in the same line. Okay, CP, DP not this is a hypothesis, and let's derive some results from this hypothesis. So at first, please recall postulate 2. Given a straight line, we are able to produce it to infinity, right? So given that CP and DP are not in the straight line, then we can produce CP to infinity. Let's suppose we produce it to E. So what we have? CPE, it is a straight line, okay? And we can apply proposition 13. If two straight lines are meeting each other, the two adjacent angles, the summation of these two angles are two right angles, right? So, which means angle APC and angle APE are two right angles. Let's just use 180 degrees for convenience. This concept had not been introduced in the elements, so we write it for convenience. Okay. And in this proposition, we already know that APC and APD are two right angles. This is a condition from our proposition. The two adjacent angles, the summation of them are two right angles. Okay, so these are we know, and let's try to use common notion 1. Okay, common notion 1 tells us if two things are equal to the same, then they are equal. So with these two equalities, we have the right side of them, both of them are two right angles, so we have APC right? So left side must be equal. And then let's apply common notion 3. If they are same, and if we subtract the same thing from both sides, the results are also equal. So we can subtract APC, okay? So that will be APE is equal to APD, right? And what we have found? The angle APE is equal to the angle APD, but this conclusion obviously breaks common notion 5. The whole is greater than the part. We can see that APD is a whole, meanwhile APE is part, so we should have APD is greater than APE. This is from common notion 5, but these two conclusions are contradictory to each other, which means our hypothesis is false. So the proposition is true, which means CP and DP are in the same straight line. And that concludes our proof. Sorry, my apology. I forgot to mention that let's say they are two right angles, okay, from the right side rather than 180 degrees. And if we want to prove the left sides are equal, at first we have to use postulate 4. All right angles are equal, right? So two right angles is equal to another two right angles. In this, using postulate 4, we know that the right sides of these two equalities are equal, and then we can apply common notion 1 to say that the left sides are equal. Okay, I forgot to use this step. And I think this is the end of this video, and in the next one we are going to discuss proposition 15. Thanks for watching. Have a good day.